Next, I want to discuss a little bit distribution of galaxies. And the observation tells us that the galaxies occur in clusters. And the size of those clusters varies. And there are two basic types. There are so-called rich galaxy clusters, and they contain more than, say, 1,000 galaxies. And let me give you an example of a rich galaxy cluster. So this one is a rich galaxy cluster. Its name is Abel 2218. You don't have to know that. I'm just giving you for the sake of completeness. Okay? So this is how a rich galaxy cluster looks like. And you can see that there are certain features here in the form of arcs. They basically arise from gravitational lensing caused by essentially dark matter distributed among the galaxies. So I find this photo quite spectacular. And of course, if we have rich clusters, then there have to be poor clusters as well. Poverty and wealth are always relative. They contain typically less than 1,000 galaxies. And an example of poor galaxy cluster is the cluster of galaxies to which the Milky Way belongs, the local group. So this is just a drawing of the local group. I got this from a NASA site, and somebody must have a good sense of humor to actually give the distances. Here is the Milky Way, right? To give the distances between the Milky Way and other galaxies in the local group in kilometers, right? Which is kind of absurd, but anyways, maybe it drives the point that these distances are really astronomical. So here, so this is a local group. The Milky Way is at the center here. Here are the large and the small Magellanic Clouds. We've talked about them before, irregular galaxies. They are part of the local group. And here is Andromeda, or M31. And as it happens, the Milky Way and Andromeda are approaching each other at a speed of about 120 kilometers per second. The distance between us and Andromeda right now is about 2.5 million light years. So when you calculate how long it would take for the two to get nearby, you get in about 4 to 5 billion years. As I said before, roughly the time when our sun will expire, when it will run out of hydrogen in its core. The collision or interaction of galaxies is much more likely than the collision of individual stars. Why? Well, if you look at this concrete example here, the typical distance between the galaxies in a cluster is maybe 20 times their diameter, while a typical star-star distance is 10 million times the star diameter. And the typical star-star distance is about 10 million times. Okay? So, because the stars are so tiny on the scale of their typical distance, the odds of two stars running into each other are not very high. They are basically zero. However, the galaxies, they are at distances that are kind of 10, 20 times their diameter. So then it's more likely that they will come close and interact with each other.